Welcome to this session of Shadow the Scientist. My name is Jamaica Marshall, and I'm pleased to serve as the Shadow the Scientist Programs Manager. I'm very excited to welcome you all to this very first session featuring the Panoptes team, Introduction to Project Panoptes, Science and Outreach. And we have an international group joining us from here in Hilo, Hawaii, myself. Olivier is also here in Hawaii. And then we have groups in Bhutan and other places. So without further ado, let's get started. I'm going to hand it over to Olivier Gouillon, who is the founder of Project Panoptes. Welcome, Olivier.
Thank you, Jamaica, for arranging this session. It's a great privilege for us to have this opportunity. So my name is Olivier. I'm an astronomer. I work at the Subaru telescope in Hawaii and also at the University of Arizona. And my research area is exoplanets. And Project PANOPTES is a science project, but also one that's very accessible to jump in. And it's about discovering and monitoring exoplanets through the transit technique. Also looking for flares on stars and all sorts of other fun projects. All of them require monitoring a very large number of stars. And so the project is optimized for that. It's made out of small unit telescopes that you can assemble and then join the network to monitor stars at a scale that would be very difficult for professional astronomers to do with large telescopes. So let's get into it. So today we'll have a very special session. We'll go to Bhutan, the Kingdom of Bhutan, where we'll spend most of our time going over what we have been doing with our Bhutanese colleagues and students. Before we get there, let's do a quick introduction of the team. So I already introduced myself. Maybe we can go to, let's do a quick trip to Switzerland. I think we have Achille on the line.
Yeah, hello everybody. So I'm Achille. I'm part of the Swiss team working on PANOPTES in the EPFL in Lausanne.
All right, and then we can go to maybe Mike.
Hey, well, good morning or good evening or good night, depending on which side of the world you're on. I'm Mike Carroll, also on the big island of Hawaii, working with Olivier and the rest of the team.
All right, great, Mike. And I think Annie will join us a little bit later. We have, let's actually go straight, I think, to Bhutan. So maybe Alka, I think you're going to do the introduction. And we also have Sobit. I just saw Sobit on the line. Hi, Sobit. I should mention, because there is not many of us, I think we would also like to hear the participants introduce themselves. So maybe Alka will do a quick introduction of the Bhutan team. Then we'll hear about who else is on the line, and we'll keep this very interactive. So you can have questions at any time. You can just raise your hand, post on the chat, or just even unmute yourself and speak up. So maybe a quick intro in Bhutan. Maybe Sobit, you want to start, introduce yourself, then Alka, and then we'll do the rest of the introductions for all the participants, and then we'll go back to Bhutan.
Okay. Hello everyone, I am Alka Subas, studying in the 11th grade, and I am a part of the light curve study. All of us are part of the Panoptes team at the Royal Academy Observatory.
Great. Sobit, you want to introduce yourself?
Okay. Hi everyone, I'm Sobit Pradhan, and I'm a physics teacher. And out here in my school, I run STEM club, and I have been part of Project PANOPTES for the last 2 years. So I got engaged to Project PANOPTES during my master's degree, and it's very exciting project. Thank you.
Thank you, Sobit. Very nice to see you again.
Yeah.
Let's go to the participant online. So maybe I can call names in the order that I see them, and you can briefly say hi. So we have Alexandre Carrel.
Yeah, hi. So I'm part of the Swiss team, and I also work with Achille.
Great, nice to see you, Alexandre. Then we have, let's see, on my screen we have Eileen Bush.
Hi, hello. I'm also part of the Swiss team, and I work with Alexandre and Achille, and there are other members of our group also in the call.
Great, nice to have you. And I should apologize if I mess up the pronunciation of your names because I don't know all of you. Next is Huckle Thumbs.
Yeah, hi. I'm also on the Swiss team. Nice to meet you.
Nice to have you. Then we have Mitokiski Mlados, and I probably misspelled your name. I'm very sorry.
No, it's okay. It's okay. No, for me, I'm Tosis from South Africa, Durban. So I met Mike during the AFASA conference. So I'm interested in this project. So I'm just here to observe.
Great, nice to have you. Then we have Naomi.
Hello, everyone. I'm Naomi. I'm from Ghana, but currently living in Japan. I work with the IOU Office for Astronomy Outreach, and I met Mike in the IFAS conference this year, and I'm here as an observer. Thank you.
Great to have you, Naomi. And then we have Yasin.
Okay, in the chat, Yassine has a message. Hello, everyone. I'm Yassine. I'm a part of the Swiss team and with Akil and the rest of the team. Sorry, I'm unable to use my mic right now. No worries, Yassine. Welcome.
Okay, great. Did I forget anyone?
I think the second Mike Carroll listed on there is Ann using one of my computers. So see if she can unmute.
Hi, everyone. This is Annie. I had to switch computers. I'm having huge issues here, so sorry, everyone. I'm the one that sent out all the emails.
Hi, Annie. Did we forget anyone? I think I went through everyone.
Yep,
All
I
right.
think you got everybody.
All right, let's get started. So let's hand it back to Bhutan.
Thank you for the great introduction. So we will be starting our presentation. So as I mentioned before, I am Alkasuba, and I will be giving you all a brief introduction of the Royal Academy Observatory. So our observatory has its roots in 2019 with the building of a Panoptes unit in Pambisa, DGI at Paro, Bhutan. So it is led by a few students and faculty members from the Royal Academy and experts from across the world. So our purpose is to build tools suitable for scientific research in astronomy that contributes research findings and enhancing the knowledge and understanding of the scientific community. Some of our goals and objectives are, number one, to become innovative thinkers. Our goal is to become creative and outside of the box thinkers. We want to be in an environment where we are encouraged to ask questions and think differently. Number two, develop research questioning. In the world of research, it is very important to ask the right questions, as it is important to finding the right answers. Number three, develop collaboration skills and awareness. We want to be in a position where we can equip ourselves to work efficiently with others, keeping in mind that each person brings out different perspectives and ideas on the table. Number 4, think globally, act locally. As much as we need to think on a global scale, it is very important for our work to have a local impact. Lastly, we believe in publication, not only for recognition, but to make a difference in the scientific community. Thank you. So now I will be handing over the presentation to my friend, Achiji.
My name is Sikmi Chogal, and today I will be talking about our consortium and the web service that we use for image analysis and image orientation. So our consortium is basically the dashboard, and it's a group of PANOPTES unit around the world that we use for a common goal. So a consortium usually refers to an association of objects or something, but in our case, it's an association of PANOPTES units around the world for a common goal, which is to look at the night sky throughout the 24 hours that we have. For example, if you look at this unit, this PAN 007 is the unit at Mount Wilson, and the PANOPTES unit 018 and 026 and 027 are the units that are in Bhutan. So since Bhutan and since the units in Bhutan and in Mount Wilson are on different parts of the world, when the unit on Mount Wilson shuts down because it's daytime, the units in Bhutan gets activated because it's nighttime here. So through this alternating time of our days, we are able to look at the night sky for most of the 24 hours that we have in our for our day. So I will be basically talking about the dashboard here. So this is the dashboard that we have for our consortium. So this is our consortium, and plans to include the PANOPTES units in Hawaii, Switzerland, and Arizona are also underway. And so if we look at the dashboard, it gives us the information about the night sky, about the sky. For instance, at Mount Wilson, we know that it's it's nighttime because here it says that it's dark, and we also know that Mount Wilson, it's dry, and we have other information that talks about the sky, and it also tells us if it's suitable to use the mount right now or not. So I will be now taking you through how we use the web service astrometry.net to look at the images that we take pictures from the units that we have. So we usually download the images from here, from this dashboard. So we go to our dashboard, and we right click on this, and then we copy link address, and I've already preloaded a image that that has done its image analysis. So this is astrometry.net, and in here we can put in the image. If we can download the image, or we can put in the a link of the image, and this takes about 2 to 3 minutes to analyze the image. So astrometry.net is usually used for image analysis and for identification of stars and objects that we can find in our images. So in our image right now, we have the Corona Borealis, and we also have the Blaze Star, which is one of the biggest projects that our observatory has been working for. So this is basically how we look at the images that we take pictures from the PANOPTES unit, and we use astrometry.net to analyze our image. So this is basically just a gist about our consortium and the web service that we use. So now in our next we have my friend who will be talking about Swarthmore.
Hello everyone, I'm Tijum Dalker, and I'll be talking about Swarthmore and AutoWisp. So Swarthmore is a website that is a catalog that helps students search for stars with planets passing around them, which are what we call transits. They combine different data from space missions and observatories, and and help us decide which targets are worth observing. And some key data for observing transits are Number one, we have magnitude. Magnitude is how bright a star is. So lower numbers mean brighter stars, so which are better for observing because because that means that the transits will be easier to detect. The transiting timing, it shows us the exact start, midpoint, and the end times of the transit. So it helps us know when to point the telescope so that we don't miss out. The elevation, it shows us how high the star is in the night sky during the transit, so that so a higher elevation means that the telescope doesn't have to point too close to the horizon where the atmosphere is thick and conditions are worse. The transit completeness means how much of the full transit that will be that we will get to observe, and depth means how much the light dims when a planet passes in front of the star. So if the light becomes much more, if there's a deeper dim then during the transit, then that means that the star, that means that the planet is either bigger or is closer to the star. So so we have here the data that we got from Swarthmore. So the test mag shows us the magnitude of the star. The start, mid, end next here, the highlighted box up there, it shows us the transiting timing. And the duration, it shows us how long the transit was there, transit lasted for. So this one shows us that it was for 1 hour 16 minutes. The elevation there, it shows us how at what degree the telescope mount was directed at, and then the depth there is also shown there. And next, I'll be talking about AutoWisp. So AutoWisp is what we've downloaded for our light curve research. It was developed by Dr. Kalyan Panov's research lab at the University of Texas, Dallas, and it was funded by the National Science Foundation. All Panoptes images are uploaded to the cloud, and through the Panoptes pipeline, we get the analysis and we get the data analysis, and it's like distributed to the global scientific community. So these pictures, we can use them for our own research, and these images that are uploaded, these are also used by astronomers, scientists who these are like resources that we are distributing to people, and we download any images that we have taken for our research and analyze them locally using our own local version of AutoWisp. Now I'll be handing over the presentation to my friend Riggs and Choten.
Hello everyone, my name is Riggs Choten, and today I'm going to share some of the exciting research that we are conducting at our observatory. So first, we are working on photometry and light curve study. Through this, we analyze the light curves of exoplanets to understand stellar variability and celestial phenomena. And second, we are working on Blaze Star research paper. It is a binary system, and we are investigating the characteristics, its behavior, and conducting near continuous monitoring using a network of Panoptes units from Bhutan to California for any signs of flaring. And we have also written research paper on Pleiades, and our studies focused on its information and historical significance in Bhutanese mythology. And we have also worked on a research paper on Jupiter, and we are trying to answer the question, can the Panoptes unit be used to determine the period of Jupiter's moon? And another thing that we are doing is astrophotography. We are using photo stacking techniques to enhance the quality of the images and to reveal the faint celestial objects. Finally, we are also learning how to write research proposals and how to get it approved by the consortium. Now I will hand over to my friend Tashikita.
Hello everyone, I am Tashi Kudrin, and what I'll be talking about is I'll be signing into Mount Wilson by through an SSH connection. So I'll be using a command line for this. So now I'm going to set up a SSH connection into the Mount Wilson Observatory. Over here, you can see once I run the command tmux-a, on the bottom half of the screen, it opens up a log, and this log is basically shows what the unit in Mount Wilson is currently doing. As we can see over here, it has taken photos and it is currently uploading it to the cloud.
We actually can't see that screen. I don't. I assume you're using the terminal. I don't see the terminal.
Yeah.
Okay, so pick the one is that the one? Here?
Is it visible?
There we go. Brilliant. Thank you.
Just explain again.
Once I log into the unit at Mount Wilson, when I run the command tmux-a, it opens up on the bottom half of the screen. It opens up a log which basically shows us the status of the unit, like what the unit is currently doing. If you see over here, it shows that once the unit has taken pictures, it is currently uploading the images to the cloud, to the Google Cloud. That is it. Now I'll be handing over the presentation to my friend.
I am Kim Wongmo, and I'm going to talk about the bench build. So bench build is an aspect of the PANOPTES project developed at the Royal Academy Observatory, and we are where we train people to build a unit without dismantling a working unit or bearing the costs of building a new one. So in the first picture, it's of a visiting faculty teaching the students on the bench, and in the second one, we went up to the ground station to fix the units that weren't working after 2 weeks of working learning on the bench. So I'll be showing a video on the bench build. Can you see the?
Yes.
Okay.
PANOPTES is a network of many PANOPTES units all around the globe, tracking and taking images of the night sky from many places.
enabling us to discover and study exoplanets, stars, etc. Here at the observatory at the Royal Academy, we have been training students to build their very own Panoptes units, a process we call bench building. Bench building is the aspect of the Panoptes project developed at the observatory at the Royal Academy, which focuses on the practice of building a unit and experimenting with the process without incurring the costs of deploying it.
Once you have built a Panoptes unit, you don't want to take it apart and rebuild it again. So to train people without disassembling an assembled unit, we use the bench build process. This approach allows trainees to learn how to build a unit from scratch without disassembling an assembled unit.
We divide the bench build process into two sections, hardware and software. The hardware refers to the physical parts of the unit, including the electrical components and the connections. Software. Firstly, you have to format the SD card by downloading Raspberry Imager, which will assist us in installing an operating system, which for our case will be Ubuntu. Loading up the Raspberry Pi imager, click the button under the Raspberry Pi device. Select your model of your Raspberry Pi. Now we have to choose the OS. For the Panoptes unit, we use Ubuntu server version as it allows other devices to connect to your Raspberry Pi. Lastly, choose your storage, which will depend on the type of portable storage device. In conclusion, bench building is important for the Panoptes project because it lets students practice putting together and testing units in a safe, cost-effective setting. This process helps spot design issues early, speeds up the development of new ideas, and ensures that the final units are high quality and reliable. By testing different setups, bench building helps save time, money, and resources, leading to a more successful project. Now I'll be handing over the presentation to my senior.
This is Zambala. Now I'll be talking about the maintenance under the operation part. So I've divided into two segments, the hardware and software. To talk about the hardware, it's all about keeping the physical parts healthy. We make sure that the camera are all in focus and are all clean. We make sure that the mount is running smoothly, and we also check whether the wires and power connections are all secure. During a windy day or when there's a harsh weather, we physically go up to the unit to check whether the enclosures is properly enclosed so that no physical parts has been damaged. And then to talk about the software, it's about keeping the control software updated and making sure that we are getting the data. We also periodically delete the data so that we will be able to save space and since it's much easier to delete the data from the Pi itself before it gets uploaded to the cloud. So in order to make our work easier and to delete it, we directly delete it from the Pi. And I've tried to place the weather status in the center, trying to say that it falls both under the hardware and software. So to share about the hardware, during a harsh weather day, we physically go up to the station to make sure that all the weather sensors such as humidity and temperature sensors are working so that we are getting the right reading which falls under the software. So basically maintenance is all about hardware and software for the better running of the Panoptes unit and to make sure that we get
good images from the unit. Now I'll be passing this presentation to Pranita and before I pass the presentation, is there any questions regarding any part of the presentations that we have done till now? If there's no question, I'll be passing this presentation to Pranita.
So hello everyone, I'm Pranita and I'll be mainly focusing on the outreach programs that we have done till now. So we have done many presentations. So we have presented about our projects to general public and to students from other schools. And through these presentations, we are able to like make them aware about our project and to make Panoptes be known to the general public. And this is us explaining about the working of Panoptes to the exchange students that we had from India. And this is also a group of students from our team who are presenting about their project to the general public at the Fest. And we also have existing and potential partnerships. So firstly, we have Northern Arizona University Flag State at Arizona. So firstly, we hope to integrate Panoptes network into any use asteroid database pipeline. With this pipeline, we will be able to derive the asteroids size, activity, rotational periods, and many more activities. And we also have University of Virginia, Morgantown at West Virginia. So we are mainly focused on the Spira project, which stands for Digital Signal Processing in Radio Astronomy. So it is NSAF research experiences for teachers in engineering and computer science site at the West Virginia University Lane Department of Computer Science and Engineering. So in our school, we have like built radio horn telescope. Through this telescope, we will be able to collect radio waves from celestial beings, celestial objects from outer space. Through this radio signals, we will be able to like analyze the data and know more about the object that has been emitting these signals. And now we also have local activities. So we host stargazing nights. So we have hosted stargazing nights with Ugyen Guru Lhakong monks and students from other schools. And even in our school, we have hosted many events. So the most recent one was the Suchinsan Atlas comet that was observed last year, in the ending of last year. And we also, we frequently like host star parties where we observe different kinds of moons at different time. And we recently, we also had a workshop and some of our members from our team went down to the Carmeling Observatory at Samsi College of Education. This is another down in the Samsi College of Education, we have another Panoptes unit. So down there, our students and faculty from our school went down there and taught the college students about the light curves study, and we also gave them a lecture about how to control panoptes unit. And we also have recently established a astronomy corner in the school newsletter. So now I'll be handing out to my friend who will be talking more about our future plans.
Hello everyone, I am Tenzin Rabgezamo, and I'm going to be talking about our upcoming outreach plans. So this is a part which focuses on how we bring space science beyond our community into a wider range of community. So first, we are planning to launch a social media platform where we will be uploading night sky photos and then astronomy facts. And we are also planning to publish a children's book with Buddhist cosmology. This book will include traditional stories about stars and astronomy to younger learners, which will blend Buddhist identity with modern astronomy, making it more engaging and educational. We are also excited to host Panoptes themed star parties. This event will not just be about looking through the telescope, but also the participants will be given an opportunity to learn how we use Panoptes unit to detect exoplanets. And at our school, we have a lot of visitors and several exchange students. So we are also planning to host poster presentation to provide exposure for them. And recently we have got a proposal from a school from the eastern region of Bhutan, which is Trashigang School. They have requested to use our unit's data to do a research. So we'll also be providing data to high school students. And then very recently, a student from the Northern Arizona University also applied for an internship at the Royal Academy Observatory. So we are soon expecting him and providing internship opportunities. So why does outreach matters? Outreach is something which breaks barriers. Astronomy should not feel distant and very inferior. It should be for everyone. We are also, it also makes the universe more accessible to everyone, every people, and then we are also hoping to build a stronger science culture in Bhutan. We want more people to be curious about astronomy, and even a single moment with the telescope also motivates someone to pursue a career in STEM fields. So we are also hoping to do that. Now I'm going to be passing on to Tantin Tashiwong.
Okay, hello everyone. I am Pandin, and as you can see out here, I'll be talking about how Panoptes has been playing a role in STEM transformation. So educational research has shown that there are three major obstacles for engaging students in STEM education, and those three obstacles are motivation, cost, and training. But Panoptes directly addresses all three of these obstacles, and it serves as a very powerful tool for educational transformation. Starting with motivation, a very effective way to motivate students is to give them a sense of ownership and responsibility. When they build, they operate, and troubleshoot their own Panoptes unit, they're not just following instructions. They become responsible for their outcomes. And with that responsibility, a real sense of investment is created in what they're doing. And when they feel that what they're doing is truly theirs, their motivation naturally increases. They become more curious, more committed to what they're doing, and also they become more willing to face the challenges because they care about the results. And also, this experience of motivation is expanded through global collaboration. As a result, students are able to engage in scientific learning in a practical and an engaging manner. And to talk about cost, one of the cornerstones or one of the strengths of Panoptes unit is its affordability. It is designed to work in a wide range of settings, including rural and under-resourced areas. The essential resources are very simple. You just need a desk, a computer, connection to electricity and internet, and it makes it far more accessible than most of the other STEM lab setups. So by reducing costs and breaking barriers for participation, Panoptes is making scientific learning more achievable and inclusive for schools and communities everywhere. And to talk about the next part of the presentation, I'll be handing it over to my friend.
Hello, so my name is Rashmika and I'll be talking about the third aspect, which is the training. So training is like one of the crucial aspect of empowering STEM education in STEM education. So behind all this success, it's the immense support from the Royal Academy Observatory has been a huge part of this. Providing online and offline field trainings have been one of the huge success stories. So one of the one of the great examples would be the recent SAMSI visit, whereby students, learners, and educators could get hands-on experience in learning and also could get immersive training. So this trip was a success in many ways, as learners could deeply engage, and the feedback that we received highlighted how much they appreciated dynamic and interactive setting. And from these three aspects, training, motivation, and low cost, the impact that the impact that we can see is empowering students and educators in STEM and building a community of responsible and engaged learners. And we also want our learners to grow, share, and learn together. Thank you.
So now we have several testimonials.
So hello once again. I'd like to talk about how my experience being a part of the Project PANOPTES group has helped me grow on many levels, like personal and academic levels. First of all, being involved in the Project PANOPTES group has been a really exciting journey for me, as it has helped me to express my interest in astronomy and technology. And I believe that like the experiences and the opportunities that you get being a part of the Project PANOPTES, it like really helps you to grow on many personal and like other levels, and helps you to develop a lot of skills. Like for example, like I have recently got the opportunity of being able to present at the African Astronomical Society conference, and I've also got the opportunity to train others in Panoptes workshops at SAMSI. Additionally, I'd also like to add that involvement in Project Panoptes plays a significant role in scholarship applications, as me and a few other students, like upon mentioning Project Panoptes and speaking about it, I believe that it like really helps it has helped me and few other students get scholarships to United World Colleges and other scholarships as well. And I would say that this is a really great opportunity. Being a part of the Project Panoptes, it is like a really great opportunity to not only like grow personally, but also on many other levels. And I'd just like to say that my journey being a member of the Project Panoptes group has been very transformative and exciting. Thank you. So I think that is all that we have for now. If any one of you has any questions, we're more than happy to answer them.
I have a question to everyone. Can you hear me?
Yes, we hear you, Annie.
Oh, yeah, okay, great. So my question is, how long have you been working on Panoptes, and how long has Panoptes been in your country altogether with the units before during COVID? And then the other question is, what are the conditions you're working on? How high are you installing your Panoptes unit? Tell us a little bit about the environment it is in Bhutan.
First of all, thank you for the question. So, Panoptis has been in Bhutan for a long time now. It's almost been 6 years since Panoptis has come to Bhutan. So, the first unit in Bhutan was installed in 2019, and the second unit here at Pangbisa was installed in 2022. And the latest unit that we have is the one at Samchi College of Education, which is the 27th unit in the world. And since in Bhutan we have since Bhutan is a very mountainous country, and since the rate of pollution is very low, it's very easy for us to operate the Panoptis unit because on most of the evenings we get a clear sky instead of having a very polluted area. But and usually if it's not for the weather such as cloudy and rainy season, we get a lot of clear skies. So it's very easy to operate here at Bhutan, and having Panoptis for almost around 6 years has helped us to learn more about the astronomical side of the Panoptis unit, and it has also opened many it has opened up opportunities for many of us to learn about a lot of new things that has not been prevalent in Bhutan and has not been introduced to Bhutan. So it's a very engaging and very interactive project that has helped many youths, for instance, like us, to get a greater knowledge of how this Project Panoptis can lead to a very transformative educational journey. Thank you. If I talk about the environment of our unit, so we have set our units on a very elevated level compared to our school. So the altitude that we have set our unit is almost at 2,500 meters above sea level. So it's very it's much closer to the sky compared to most part of the world. So, and we usually have weatherproofed stations, which means that the weather conditions do not affect the units much, but regularly we have to do the maintenance for it too. And so I think if that answer your questions, so that's all we have. So if any more questions.
Yeah, thank you for the response. I have one more question. Sorry, I'm hogging all the questions. I also believe that you have started an observatory in Bhutan, correct? Through the installation and through your work with Panoptes. And I believe also that on this chat we have Mr. Subit, who also became a teacher and has started his career, his astronomy career, and his teaching with Panoptes. Can you elaborate on that as well?
You want me to elaborate?
Yes, please.
Okay. So back in 2022, I was doing my master's degree in physics in Samsi College of Education, and there I got the chance to be part of the Project PANOPTES. And Oliver, Joe, and his team, they taught us how to build this Project PANOPTES, and I was part of the team along with other members. And as a teacher, I feel this is a great platform for the teacher as well as the student to get the authentic science, whereby the students have the hands-on learning activities, not only theory, and they get real life application of whatever they are studying in especially like space physics. And in Bhutan, space physics, it has a lot of scope. And I think this Project PANOPTES, personally, since in the childhood itself, I was interested in astronomy, and I feel through this Project PANOPTES, it has helped me in learning a lot of like skills, be it coding, or it also in knowing different kinds of hardware, software system, and also about the astronomy. And moreover, it gives us a great opportunity to also find the exoplanet. So maybe in Bhutan, in near future, we may be able to find the exoplanets. So it gives a great opportunity to find exoplanet and also to know about the stars and other kinds of planets and all. So it is helping the learning of astronomy. And I feel maybe in near future, since a lot of transformation in education is going on in Bhutan, so I'm hoping that in near future, maybe this Project PANOPTES would also be part of our curriculum. And in that way, I think in all the students in Bhutan can get hands-on activity through this Project PANOPTES. And maybe and through that, in future, I'm hoping that we can also have scientists, innovators from Bhutan as well. So that's why I feel this Project PANOPTES is a great platform for the teachers, because I also get very excited to learn all about the astronomy, and looking at all the students of Royal Academy, it gives immense pleasure to see the students doing all the work of Project PANOPTES, and they're learning day by day. So as a teacher, I think it is a great encouragement for teacher also to see the students doing great work through this Project PANOPTES. Yeah, that's it. Thank you.
Thank you so much.
Do we have any more questions?
This is Olivier. I would like maybe one of you to tell us a little bit about the science that you're doing. I understand that you're starting to use your unit to follow the blaze star, and you're also starting to do photometry. So maybe one of you can tell us a little bit about that process.
So what we're currently doing right now, like in like photometry, especially like our light curve group, like our main objective is to like research like using light curves. So what we do is right now we use the AutoWisp software, which is on which we log into by like setting a connection, and over there we upload images from our unit and we check on it regularly. So then at the end, like it's quite a lengthy process, but at the end we are able to like generate some light curves, and which we like. And we also use NASA's exotic software, in which we upload like we sometimes use the images from their telescopes and sometimes from our own units. And through this is how and then like we all learn how to do it together and teach others, and this is how we do our light curve research.
Thank you.
Are there any questions from our virtual participants? Any other participants? You can put them, you can unmute yourself, or you can type your questions in the chat.
I think somebody was about to speak out of your group. why don't you come forward and tell us what you wanted to say? And after you said it, my question is about the new observatory that you have and how you see yourself, how you see Panoptes helping your future career.
So I'll be answering that question. So about the career. So through exposure to Panoptes unit and working with the Panoptes unit, uh, we are able to develop more interest, and we are able to like be more open about like be more confident about like pursuing careers in astronomy, because in our country there aren't like many astronomers to like who can inspire us right now. So I think through working with Project PANOPTES, we are able to like be more confident and all that. And through we are able to, by working with like we are able to like do researches and all through the Project PANOPTES. So through this we are able to like be more curious and willing to learn more and learn more about the universe and all that. That's all from my side.
Thank you. Thanks for your answer.
To answer the questions that you asked about the observatory. So in the past, we did not have an observatory in our school. We used to operate under the name as an internship called Space and Tech. But now, since we thought that we have come a long way from being only the Space and Tech team, we have done a lot of processes such as doing light curve studies, doing a lot of research papers. So we thought that having an observatory will be suitable for this one. So in usual terms, an observatory is understood to be a place where there are a lot of equipments which are used to look at the sky and do a lot of astronomical events. But here at the Royal Academy, we understand the observatory to be a group of people working together in order to have a common goal, which is to make space learning accessible for everyone, regardless of their background. So here at the Royal Academy, we are operating as an observatory, not as an like having a lot of equipments to do this and that, but rather to work together, to collaborate, and to produce and to be productive in order to lead to a interactive and in order to instill an interactive and dynamic space mindset in the people who are willing to take part in it. So I think that's our understanding of the observatory here. So if there are any more questions, we'll be answering them. And if no more questions come up, this will be the end of our presentation.
Jamika, is there any other question on the chat?
There are no other questions in the chat. No.
All right.
Mm-hmm.
Well, thank you very much, the group in the Royal Academy. This was really wonderful to catch up with you and see a very high quality presentation, and also to hear that you feel inspired to continue working in this direction. That's clearly one of the main goals of our project. So yeah, I'd like to thank everyone who joined today, and especially also thanking Jamaica for setting up everything for us.
It was absolutely my pleasure. It is an honor to facilitate this kind of international connection. We're all brought together by this incredible project, PANOPTES. And before we wrap up, there is another member of the PANOPTES team in the background there, Joe, who's been one of the people working with this amazing, brilliant group of young people. Joe, could you just say hello to us and maybe briefly talk to us about your interaction with this set of this group of scholars?
Hello. I can't tell you how proud I am of this group of individuals and how hard they work and the excitement they bring to my life and the great opportunities that PANOPTES and Olivier and the PANOPTES team has afforded me. So it's been awesome. It's been wonderful. And all credit goes to the individuals here with the presentation. Great job. Now we're on our way to the cafe to celebrate.
A well-deserved celebration, absolutely. Let's have Olivier or Annie or any of the other members here of the PANOPTES team have the last word.
Yeah, thank you very much, everyone, for joining. Just as a concluding remark from my side, we plan to do sessions like this in the future, changing a little bit the topic, having a different group sort of take the lead in presenting. So stay in touch with us. We'll be announcing future sessions like this one, and we're really hoping also that this becomes helpful for students to work with other students in other countries. So we aspire to be a project where students work together locally, like we heard today in Bhutan, but also across the whole world, connecting schools, groups of students to other groups of students to do science projects that require multiple units to work together and multiple people to work together. I don't know if anyone else has any other concluding remark. Otherwise, we can probably wrap up.
Excellent. Thank you so much, Olivier, Joe, brilliant students there in the Kingdom of Bhutan. Mike, Sobit, Akil, Annie, Eileen, Yassine, Huckle, thank you all so much for joining this very first session of Shadow the Scientist featuring Project PANOPTES. We look forward to having you in future sessions. Have a good rest of your day. Aloha.
Thank you. Bye.
Thank you. Bye-bye.
Goodbye.
Thank you. Bye.
Thank you. Bye.
Bye-bye.